In this problem, what is given is the current through 8 ohm resistor, which is equal to 0.5 ampere. And now you need to find it out the current through 2 ohm resistors. And the applied potential is not given. The only information is given is the resistors and the current through 8 ohm resistor, which is given is equal to 0.5 ampere. So you know the current through this resistor is 0.5, and that's all given. Okay, let's call this one as a R1, R2, R3, R4, and R5. So we can call this as an I2. So we know R2 and we know our I2. If we know R2 and I2, we can find the potential difference between these 2 points. So what we call as a V2, the potential across the resistor R2. How do I find the potential? The potential is simply equal to I times R, which is I2 times R2. I2 is given 0.5 and R2 is given 8 ohm times 8. We get the 4 volt. Okay. So now, we know now the potential across R2. The same potential is across R1 because R1 and R2 are in parallel. Since R1 and R2 are parallel, we have the same potential. So if you know the potential, I can find it out the current. Let's call this is a current I1. Alright? So now I can find it out I1. How I can find I1? The I1 can be given as V1 over R1. And V1 is exactly equal to V2, which is V2 over R1. The V2 is generally calculated as 4 volt and the R1 is 16. So we have 0.25 ampere. Okay. So we now calculated the 0.25 ampere here, and here we have 0.5. So the current here through I3 is the sum of all these currents, I1 and I2. So the current I2 comes this way, I1 comes this way, and they combine here at the junction. You can also apply the Kirchhoff's, the first rule or the junction rule. So the current I3, which is the outgoing current here, is equal to the incoming current, which is I1 and I2. I1 plus I2. Alright? So I1 is 0.25 and I2 is equal to 0.5. So the total current is now 0.75 ampere. Okay. So you find it out the total, the current. And now we're going to find out the potential across R3. See, so the potential V3, if you know I and R, you can simply find it out the potential by using the formula, which is I3 times R3. What is I3? 0.75. And what is R3 is 20 ohm. 20. If you just do the math, it's over 105, 15. We got 15 volt. This is 75 over 100, so 5. So we get the 15 volt now. Let me move to the other side. Okay, so we now find out the V3 now. Our goal is to find out the current here, but we do not know the potential. The potential across R4 this is R5. is the same as the applied potential. Now, you see, this is the 15 volt and potential across here is the 4 volt. So the total potential, what you call the B applied now, B applied or the total potential is equal to V2 plus V3. V2, or we can call it simply V1 because V1 and V2 are exactly the same, plus this potential. This potential plus this potential is exactly equal to this potential. This is equal to 4 plus 15 and we have 19 volt. Excuse me. So we got the total potential now. So the applied potential across this 2 ohm resistor is now 18 volt. So how do I find the current? We call the current as this current, we call this as an I5. Okay, so I5 is given by the potential across this resistor, which is equal to the applied potential V applied. Because you see this potential, these two are in parallel. So the potential across this resistor is exactly equal to the potential across this resistor, which is equal to the applied potential divided by R5. This is equal to 19 volt divided by 2. If I do the math, then I'll get 9.5 ampere current. Okay. If you need to find out the current through this resistor R4, what do you do? If you need to find, then V applied divided by R4. So 19 divided by 6. That should be your answer. Okay. Thank you.